Okay, let's do number 4 on page 44. Sickle cell anemia is a condition in which red blood cells change shape. It is recessive to normal shaped red blood cells. So let's start there with our legend. Normal is dominant to sickle cell. In addition, individuals that are heterozygous for the sickle cell trait do not develop sickle cell anemia and are resistant to some strains of malaria. Determine the phenotypic and genotypic ratios of the offspring in a cross between a man who has type O malaria-resistant blood. So the man has type O malaria-resistant, which we said was heterozygous blood, and a woman who is heterozygous for type B blood. The woman does not have sickle cell anemia and is not a carrier, which means she is homozygous dominant. So she is heterozygous for type B blood and homozygous dominant for the sickle cell trait. All right, next step is to find the gametes. So for the man, we're going to have little I, capital N. Next one, using the FOIL method, little I, little n. Third one, little I, capital N. And the last one, little I, little n. We're going to cross out the repeats because we don't need to write things twice in our Punnett square. The female is going to have I, capital B, N. Another one, little I, N. And a second little I, N. Again, we will cross out the repeats using only unique gametes in our Punnett square. Okay, then we'll cross the individuals to find the offspring. Make sure you keep the blood types together and then the sickle cell trait together. And check back what we're looking for. Determine phenotypic and genotypic ratios of the offspring. So we have type B normal, another type B normal. So phenotypically, 2 type B normal. Next we have type O normal and type O normal. So 2 type O normal. So remember, if you have a 2-to-2 ratio, you always lower it to 1-to-1. So I'm just going to cross that out, and it's 1-to-1 ratio. Genotypically, we'll look at them, and we see IBI with 2 capital N's, homozygous for the dominant trait, is different than heterozygous, and same with the other two. So genotypically, we have a 1-to-1-to-1-to-1 ratio. And we're done.